Okay, now we're going to solve equations using algebraic techniques versus graphing techniques. And this is called substitution. So we're going to take one equation and substitute it into another equation and find a solution. It's very similar to composite functions. Okay. So the substitution method, right? We're going to take one and place it into the other, substitute it in. You will solve the equation for one variable. That means that we will eliminate one variable through substitution and solve it. All right, so for example, we're going to solve the following systems. 3x minus y equals 6 and negative 4x plus 2y equals negative 8. Now, we're going to solve the first equation for y because y does not have a coefficient on it. It's the easiest one to solve for. This one has a coefficient you have to divide through. Okay, the first one we're guaranteed not to get any fractions in the solution of the first equation. So solve the first equation for y, right, by subtracting 3x from both sides, dividing through by negative 1. Make sure you change the sign on both things. And now we're going to take this y value and we're going to substitute it into the second equation for y. So there it is right there. So where there was once y, now there is 3x minus 6. So 3x minus 6 goes in, so we replace the y. Distribute the 2 and start solving for the x. Okay, so distributing the 2 gives us 6x minus 12, so 4x plus 6x will give us the 2x minus 12, add 12 to both sides, so 2x is equal to 4, x is equal to 2. Now, we're only halfway done. There is more because I need the y value also. So now that I have the x value, I can find the y value by substituting it into one of the equations where x is. So they're already both solved for y, so it doesn't really matter, but we'll just place it in this one. Y is equal to 3x minus 6, x is equal to 2, so you have 6 minus 6, so it's 0. So we have 2 comma 0 as a solution, but wait, we have to check to make sure it works. So we're going to place this value into the equation and solve. And it is true for the first equation, and then we're substituting 2 for x and 0 for y, and we get the second statement, second equation is true also. So that means the point 2, 0 is a solution. So now if you remember from graphing, there are three things that could happen. We could have 1 point for a solution, which we have here, okay? And then, we can also have possibilities where it does not work. That means they're parallel lines, or we can't find a solution when we substitute in, can't find a solution, or it's equal to each other, right? So you'll see that. Okay, so solving for linear equations using the substitute method, solve for one variable, substitute it in from step 1 to the other equation, solve the new equation for the variable, substitute that variable value back in, okay, and check. Okay, so let's look at example 2. So we have our two equations. This one's already solved for y. That makes life easy. So we're just going to take that and plug that into y. We don't have to do any work at that first step since it's already solved. So we're going to take the y in the 8x minus 4y and substitute in 2x minus 5 for y. So we do that, distribute and solve for the x. So 20 equals 20. So the x's went away. You notice we have no variables left here. So all the variables went away. So 20 is equal to 20. So we don't have a solution for x. So when you get this result, right, indicates that the two actually represent the same line. So they're exact same line. So there's an infinite number of solutions when this happens. Infinite number of solutions. So if they're equal to each other, infinite number of solutions. So when I solve through substitution and I get two values equal to each other that are the same, and all the variables go away, in other words, all the x's or the y's disappear depending on what you're substituting for, then you have an infinite number of solutions. Okay. Ooh, sorry, I went a little fast on that one. So it consists of a system of linear equations that are dependent equations. We didn't talk about the words. Okay, just know that there is an infinite number of solutions. Okay, so, let's look at this next example. Okay. So we have both of these. We're going to solve the first one for y because it doesn't have a coefficient on it, so that's the one we're going to solve for y. Right? Okay, so there we go. Y is equal to 3x minus 4. Those are the steps of how to do that. Now we're going to substitute it into the second equation. So we're going to have 6x minus 2 times 3x minus 4. So we have x minus 6. And look at this. Now we have 8 equal to 4. That is a false statement. That is not a true statement. Okay, so when we get this result, the lines are parallel and never intersect. Right? So there is no solution to the system when you get that result. Okay? They're said to be independent. They're said to be independent, though, right? Because they're not intersecting each other. Okay. So in this case, or we're solving by substitution, we have all 3 methods right there. Where they are parallel, coinciding, and then the first one where we had only one solution.